Hello everyone, this is Anurag Chen. I'm a developer advocate with Thales and I'm currently working on some of the data protection suite tools that are part of the Thales CipherTrust family. In this multi-part series, and this is the first part of that series, we will work our way to have a three-tier web application built from scratch. So three-tier as in like front end, back end, and the database, and then add data protection to that application transparently without you requiring to change the application code itself. So you can follow this tutorial to add data security to your existing application as well. But we will walk through some of the steps in terms of how you can write a quick application, a small application that consumes the personal and financial information of the user, and how you can secure that information to meet various compliance requirements. So the three tiers that I'm talking about, they are the front end using React and Express JS, and then a backend written in Spring Boot, and I'm using MongoDB as the data storage. You can definitely use other frameworks, but just for the purpose of this particular demonstration, I'm using these technologies. The application that we are going to work on is for storing credit card information of the users. So some of the example can be, if you're working on an e-commerce application which stores users personal information, or if you're working on a financial application which again stores critical information about the user like social security number, and other details like credit card number and the CVV, etc. We will then add a Thales Trust data protection gateway to that application. And the beauty of that product is that you don't really need to make any changes to your application to add things like cryptography or security. You can add data protection gateway as a standalone container, and then we will work through all these things, but you can then define certain policies based on which data can be protected and revealed, and all these things can be done for free. So Thales Effortress Manager has a community edition where you can try out the APIs. You also get licenses for data protection gateway, and you can use those free tools for securing the data in your own application. This is the basic architecture of the application that we'll be working on. So it's all the three layers. We will be deploying them in Docker containers. So the front end UI again with React and Express JS, the API layer with Spring Boot controllers, and the database. All these three components, we at the end of this multi-part series, we will be deploying all of them in a Docker container, and add the data protection gateway container to it for transparent encryption of your data. And all of these things I'm going to do through docker compose.yaml, but you can easily modify your application code to work in another other environments like Kubernetes. Some of the prerequisites before we dive into the actual code. It's good to have knowledge of React.js, bit of Express.js, Spring Boot, or Java, Docker itself, and understanding of the REST API ecosystem. Although we will be working on the application from scratch, but if you already have some information or some knowledge of these frameworks, it will be definitely helpful. My development machine, I use Spring Tool Suite for creating Spring Boot applications, Visual Studio Code for React, and then I'm using Docker for desktop to run my Docker files, the Docker Compose itself. But you can definitely choose your ID of your own preference. It should be okay. So in this part, I will be working on the backend development piece. I will post all of the links in the video description, but I have already created this app. It's hosted on GitHub, so you can follow that particular code or you can follow along. But yeah, in this part today, we will be working on the backend API development using Spring Boot in STS. So this is my development machine. I am using Spring Tool Suite. So I'm going to create a new Spring Boot project. I am going to name it, you know, sample bank app, and I'm using Java version 17 with Maven. But again, you can use Groovy if you want. You can use other build tools, but that's perfectly up to you. The build tool of my choice is Maven. I'm going to give some names here, and yeah, let's use this. Okay. Next, I am going to add a couple of Maven dependencies. So one thing is Spring Web. I'm going to create some REST API controllers in this app. So I would need Spring Web package. I am going to use MongoDB as we discussed earlier. So I'm including Spring Data MongoDB as well. And that's it. That should be pretty much it. But we can add, later we can add more packages to pom.xml if you want. So yeah, let's wait for a few seconds while you know the IDE is importing all the packages and everything. So we have our sample bank app created. Now we are going to add, and it's a very simple application. I'm just going to add a couple of REST API endpoints. It's just to give you an idea how you can add data protection gateway to such multi-tier applications. So I'm going to work with a very simple implementation of this application. So let me create few packages here just to add our classes to. And I'm adding a bean package where I will be storing all the relevant beans. Then the controller package, that's where I'm going to add the REST API controllers, our REST API endpoints, and a couple of more. So one of them is the model. We are storing everything in MongoDB, right? So we have to have a model class which mimics our database entry, right? And then finally we need one repo package. You can put all of these classes in one package as well, but yeah, a bit of organization so that when we want to expand our application, we can easily do it. So I'm going to start with the model class. So we would want to have a database model class for storing the user information or the credit card information. So let's call it card data model, or yeah, card, card details model, and finish. So I'm copying some of the content from the GitHub page just so that I don't need to type in everything again and again. So these are some of the fields that I'm intending to save in the database. So you can see I'm saving social security number, the credit card number, the CVV number. So these are the kind of things if you're making an application which stores the information which is personal to the user, or financial information, you need to be PCI compliant, to be compliant to some of these requirements. So you need to secure that information in a way that it cannot be decrypted, or it cannot be, even if it goes into wrong hands, that information should be useless, right? So we are going to throughout this application, we are going to encrypt that information using Thales CipherTrust platform. Okay, since this is our MongoDB document, so let's add an annotation. MongoDB stores everything as all of the things as documents. So yeah, I'm using so we have included the Spring. Okay, let me quickly open the pom.xml file. So we have included the Spring Boot starter data MongoDB that does contain all the required dependencies to work with MongoDB and Spring Boot. So I've defined this card details model class as an equivalent to cards collection in the MongoDB database, right? And since user ID is our primary key, another annotation which will make sure that this is a primary key kind of object in the database, right? So now we have all the fields. Let's quickly add some of the getter setters, and you can use libraries like Lombok, so you don't need to do it. But yeah, I'm just for the sake of this demonstration, I'm just adding some of these redundant sorry boilerplate code right now. Okay, and our toString class method. Sorry. Yeah, so this is pretty much the code for the model class. Again, we have added some of the fields which we want to retrieve from the user and store in our database. Once this is done, we can now go ahead and create our repo interface. So, repo interface is basically repository interface. So, I'm going to create, and again, this repository interface is something which we are going to extend the Mongo repository, and we can perform various CRUD operations, create, write, update, delete operations on the DB through this repository interface. So let's call it card data repo, and it's an interface which we are going to extend with Mongo repository. And since this repository is of type card details model, so I'm going to use this here as the model class, and this is basically the primary key type. So the user ID is of type string, and an annotation to make sure that the Spring framework understand what we are doing here, repository. So yeah, that's pretty much the code for the repository interface, and should be able to close this. Once this thing is done, now we can start adding some of the beans. And beans is basically, we are since we are going to make REST API endpoints, so we need to consume the incoming information as well as send data out. So I'm going to create certain beans which are going to take the REST API input and generate the REST API output. So one of the class that I'm going to have is API response bean, and again I'm copying some of this information from my GitHub page. The link to that is part of the video description. But these are the three things that I'm going to send back as the response of the API, right? The status, any message, any details to it. And again, I'm going to add the getters and setters, constructors, and a toString method. We might not be using all of these, but yeah, as a standard practice, we can definitely add all these required methods. Then we will be fetching the information from so when the UI or when someone calls this REST API, they will be sending that user information, right? Like the SSN, the credit card number, the CVV number. So we will create a class, a Java bean, which will just hold the information that is coming from the API call. So I'm going to call this as card details bean, and these are the fields that I'm interested in. So, as you can see, this is pretty much same to what we added in the model class. And as I said in the beginning, this is a very simple API endpoint. We will get the information, from UI, which we will develop in the next section. So we will fetch that information. We will take that information from UI, all the user information, and then we will pass on that information to the database. We will just save that information in the database. You can definitely expand the simple functionality to add more and more things, like if you want to utilize this particular piece of code in your own e-commerce application, you can do it. But yeah, the idea is to showcase how you can secure the data which is being processed by your APIs transparently using Thales Data Protection Gateway. So again, some boilerplate code. Yeah, pretty much that's it. Now, finally, we are going to create our controller, the actual APIs, and let's name it card controller. So this is where we are going to define our REST API endpoints. So let's make it official. Let's make Spring understand that this is a REST controller and how to handle the information. We would need the repository class that we created. We would need that interface here so that we can perform database operations. So I'm going to auto wire that interface here. Private data repo, and let's call it MongoDB. That's we are just including our repository interface here. Now we are going to create the API which is going to handle the get request. So I'm going to add two API endpoints. One is where the information is received by the API and we save that information in database, and another endpoint is get all. So basically, if someone comes asking for the cards information, we will create an API for fetching that information, right? So I'm going to first create the post API, which is going to store the data in the database. So I want to return the information in form of API response bean that we created. So let's say save credit, save credit card, right? And the information that is coming in, we created this card details bean class. So I'm expecting that the information of the data that is coming in, the JSON that is coming in for this particular API will be of that form. So the request body is of type card details bean. Let's call it bean. Uh, hmm. Okay. And let's import this. Okay. So now we will write all the logic here. Mm, I'm going to create a response variable which I can send at the end. And let's put in that operation of securing the database securing the information in database and try and catch. So let's first we will populate the model, sorry, not a bean, the model uh, with the information that we received as part of this API call. And let me just copy some of the information, some of this code from the GitHub repo. So I'm doing, pretty much a very, very simple operation. Bean, this card details bean, the input data, it has all the information that we want to store in the database. So I'm just copying that bean, and there can be, definitely there can be easier ways to do it. But yeah, again, the idea is to demonstrate how you can secure the data. So I'm just, following some of the basic coding practices, nothing advanced here. And once we have our model class populated, we can just go ahead and save that card in the database. And I'm going to populate this uh, response dot status. I'm going to make it a success, and I'm just going to add new card added. Okay, we have written our code. Let's catch some of the possible exceptions here. And in that case, we can send a custom error message saying that it's a fail and database error. And to catch any other generic exceptions, we can add another catch. And this time we can say it's an internal server error. And at the end, we can return the response. That's it. So this is the basically this is the method. Now we have to convert that into a post mapping so that it can act as a post API endpoint, right? And for the endpoint, I'm giving it API cards state. And let's all also add one thing, cross origin. So we will discuss this a bit later, but to be able to test out everything locally, we need to add the cross origins here, right? And just for the sake of this demonstration, I'm going to allow everything in the cross origins. Not the best practice, but just for the sake of this demo. So this is basically a very a simplistic example where user is sending the information, the person information as well as the card related information, and we have an API that is going to read that and store that information back into the database. We will add another endpoint, and this time the endpoint is going to be for listing uh, the cards information, right? So card details bean. Okay, I need to create one more bean here, and let's call it card list response bean dot java. So, in this particular API call, this get, list API, we will be returning a list of cards that are associated with either one user or all the users, right? So I'm going to create in the front end, I'm going to create an admin layout as the, as well as a user layout. So while a user can add his card or card information, or user can see his information, the admin should be able to see everything, right? So let's create this, and the three things that I would need in this particular response will be the status message and a list, sorry, and a list of all the cards, right? So card is represented by the model class, and again I'm going to add some boilerplate code. That's it. uh, Now the get API, and let's call it a get mapping. Um, yeah, API cards list, and I'm going to pass the ID. The ID can be all. We will write the code here, but I'm basically handling two use cases here. If an administrator wants to pull all the cards, or if a user wants to pull the card by his user ID, right? So, and again, I'm adding the cross origin star, and this time I want to return the response of this time. Oh, sorry, this time. List cards. And since we will be expecting, okay, since we will be expecting the ID or all as part of the path parameter, the path variable, I'm going to add the path variable here, path variable that is identified with the identifier ID, and I'm storing that value in ID field. Oh, sorry. Okay, so we have yeah, we have the basic method set up. Let's create a response variable of type card list response bean. And now we are going to query our database for all the stored cards, or the cards which match a particular user ID. And we are going to populate the response object with that information. So I'm going to create a list of cards first. Mm. Uh, Cards equal to new array list card details model. Again, DB, the database, it's a Mongo database, so it will store all that information as list. That's how we are going to retrieve the information from the backend. And within a try catch, a quick check if ID equals all. So, assuming that a backend guy, a support guy, or an administrator is fetching all the accounts. So, if it matches all, then my list of cards should be Mongo repo dot find all. So, find all is a helper method in the repository class or interface, which will return all the records which are stored in that particular collection, right? However, if we want the cards which are specific to a particular user ID, we will pass. Sorry, I will. So what we are doing here is we are finding the list, or it can be just one. We are finding the data with a particular ID, right? And I'm adding that information, the record that I found by this particular ID. I'm going to add that information in the cards list. So at the end, either I'm going to return all the cards, or I'm going to return that card which is specific for that particular user ID. I have my cards populated, so I'm going to add that to my response object with a message success and cards as cards. So now what I've done is, we have all the cards or a specific set of cards retrieved. I have just populated that information in the response object that we created. And now we are just going to add the similar catch blocks if it is a Mongo exception, I'm going to send a fail. I'm just going to add that my set cards is set to null, and I'm returning the response. Okay, that's pretty much it. I have a local instance of MongoDB. I've that thing running in a Docker container. So I already have a MongoDB running in my local machine with this DPG database or collection created. We will go through some of the steps in terms of how to run MongoDB in Docker container in the upcoming videos in this series. But yeah, for now, just assume that you have MongoDB running in local machine. I'm just going to add a few more things to the application.properties file, because when we start this application, it is going to look for that MongoDB instance so that it can interact with. So the information that, or the MongoDB credentials that are specific to my local machine is this, and I'm just going to change this to localhost. You can definitely configure MongoDB, or if you already have a MongoDB running, you can use that as well, right? This is my setup, and now let's run this application. So remember, it's just still a API endpoint. The end goal is to achieve the three-tier layer and Dockerize everything, and then eventually add another Docker container, which is Thales CipherTrust Data Protection Gateway. So as you can see, we are storing everything in plain text right now, and that is not exactly compliant if you talk about users' personal and financial information. We would go through the application development, for that three-tier layer without data protection first, and then I will show you how you can just add one more container to it, and that's it. I mean, you don't need to do any code changes to your application. You add another container, add make some configurations in Thales CipherTrust Manager, the free version, and that's it. You have data protection added to your application without changing even a bit of code, right? So let's run this, and hopefully everything runs fine. So I'm going to run this as a Spring Boot app. I've defined a server port to be 8080. You can pick anything you want, and I'm going to run this thing as a Spring Boot application. And if everything goes well, we should have our later. We can quickly test this by running this endpoint. Of course, it will not return any data because we haven't saved anything yet. We can do that through Postman, or we can do through a UI that we will build in the later parts of this video. But for now, I'm just going to run 8080 and this endpoint. I should get a blank list. Yeah. So it says the status is success because there was no error in the database, nothing, no more exceptions. But the cards list is empty, so it is querying the database, and it is finding the database to be null. So that's it for this part. In the next video on, we are going to discuss the front end development, where we will be creating the UI using React and Express, and we will also tie that UI with the API which we have just created, and so that we can have an end-to-end data flow created, and then in subsequent parts we'll also add Thales Cephas data prediction gateway. Okay, thanks for being with me. We will see each other in the next part. Until then, please, if you like this video, please like or subscribe on our YouTube channel, and we will keep on adding such content. Thank you so much.